So the last video you were introduced to logarithms, and logarithms are basically a way to represent exponents. Sorry about the bell. So we've got three properties of logarithms that we're going to talk about. And first I want to do a little investigation, then we'll write down the properties. What do you think you would get if you took log of 2 plus log of 4? Well, it's going to be some weird decimal. I know that because if I took log of 2 plus log of 4, I'm getting some weird decimal. Okay, that I know. But I want to know what it's equivalent to. And common sense tells me that if I took log of 2 plus log of 4, that would be the same as doing log of 6. Right? Yeah. But it's not. And that's because logarithms are a step up from other things we were working on. They're exponents. They're up, like exponents. So instead of them condensing using addition, let's condense them using multiplication. So log of 2 plus log of 4 actually equals log of 8. Which is now one term. We've simplified it into one term. So there's times where we want to condense, that's going this way, and sometimes we want to separate it out. Let's do another example using this property. What if I had log of 3 plus log of 4? How did they condense? Well, that would be log of 12, because 3 times 4 is 12. Now let's think about if it was subtraction between log of 8 minus log of 2. Well, common sense says 8 minus 2 is 6. So let's see, is log of 8 minus log of 2, is that going to be log of 6? That 0.778? It's not. So, because it's not the same, it's a step up. So if I'm subtracting here, if I was adding, I multiplied the two arguments. So what do you think I'm going to do? Let's try 4. 8 divided by 2 is 4. That's equivalent. So log of 8 minus log of 2 is the same as log of 4. So I can combine them by dividing them. So if I had log of 15 minus log of 5, that's going to condense into log of 15 divided by 5, which is log of 3. Now the next one I want you to think about for a second. 2 log of 3s. Well, that really means I have log of 3 plus log of 3. And we just learned that rule. That would be 3 times 3. That would be log of 9. Or I could shortcut it, log of 3 squared. Now, why would I want to shortcut that? Well, if I had 5 log of x, do I really want to rewrite that as log of x plus log of x plus log of x plus log of x? No. I want to shortcut it and know that would mean I'd have log of x plus log of x plus log of x plus log of x plus log of x. And when I condense it, it's going to be x to the 5th. These are the 3 properties of logarithms we're going to work with. So, to get that product, and this works for any base. I just used base 10 in the calculator because that's what it has. this is equivalent to having the log of m plus the log of n. I can condense them by multiplying the arguments together. So if I have log base 2 of 7 plus log base 2 of 4, I can condense them into log base 2 of 7 times 4, which is 28. Log of 25 plus log of 4. That's going to be log of 25 times 4. That's log of 100. Hey, wait a minute. That one, I think this is log base 10. It is. That actually simplifies even further. It's just a 2. And that's because 10 squared equals 100. Ooh, this one looks so hard. Log, it doesn't matter what the base is, 2x plus log, doesn't matter what the base is, of 4x squared. So the rule says I can condense it by multiplying those two together. Well, that's easy. That would be 8x cubed. Now, what if I wanted to work backwards and expand it? How can I write 6 as a product? How can I write 6 as two things being multiplied together? Well, that's easy. I could write 6 as 6 times 1, or how about 2 times 3? Now, if I'm expanding it, that means instead of having it all condensed into 1, I'm separating it back out. That's the same as log of 2 plus log of 3. How could I expand 45? Well, there's a lot of different ways. I could do 45 times 1. I could do 3 times 15. Maybe 5 times 9. So I could rewrite this as log base 7 of 5 plus log base 7 of 9. Ooh, what's the product here? Well, the product is 5 times x. So that's really times, so I can rewrite this as log base 2 of 5 plus log base 2 of x. Now, one thing I want to note here is notice that the bases are the same. So these have to have the same bases and the end result as the same base. This one didn't have any base written, so it didn't have any base written. Same base, same base, same base, same base. They have to match. Kind of like the combining like terms thing. Quotient property. The quotient property said that division inside was the same as taking a logarithm minus another logarithm. So let's start with the condensing. That's the easier part. Condensing. So if I'm going to take a subtraction, I'm going to condense it with a quotient, with division. So that's going to be 24 divided by 8, which is a 3. Ooh, base 3 and a 3. So 3 to what power gives me 3? That actually gets really, really simple. And I think I promised that I was going to show you that we introduced that change of base thing. I could do this as log of 3. Whoops. It was a fraction, sorry. Log of 3 divided by log of 3, which of course is going to give me 1. But I wanted to show you, if you're using one of the school's calculators, if you press the alpha button and then this window button. So alpha and then the y equals gives you a fraction. Alpha window has an option, number 5, that says log base. I can actually type in this. Now the only time we want to simplify it is if it's going to give us a nice pretty whole number, or maybe just a fraction of 1/2 or something like that. You wouldn't want to put an ugly decimal down. That's not simpler, that's uglier. All right. Log base 2 of 15 minus, I think I could have simplified this one straight from the beginning. I'm doing it using the quotient property. But let's really think about what's happening here. If I have log of 15 minus log of 15, I'm going to get 0. And this does end up giving me a 0. Here, let's practice this. Alpha window, number 5 is log base, 2, 1. It is 0. Condense. Subtraction condenses using division. So x to the 9th divided by x squared is going to be x to the 7th. How could I divide out and make this into a division problem? So if we're expanding, we're separating it out into two things. So let's think of some ways I could write 4. Oh, how about 12 divided by 3? I like that. How many ways could I make up a division problem that gives me a 4? Oh, you could have done 40 divided by 10. You could have done, there's so many options. But that's the one I chose. Oh, this one's already a division problem. It's already a quotient. So I can separate it out. Minus log base 5 of 3. This one's already a division problem. So it separates out using subtraction. Ooh. Now let's remember on these. Okay, so this number in front really means I'd have 5 of these being added together. Log base 4 of 2 plus log base. This is really equivalent to that being an exponent. Nifty. So, to get an exponent, we would have had this to begin with. So a number in front becomes an exponent. Number in front becomes an exponent. That's the shortcut. Instead of writing it 7 times, that's ridiculous. Number in front becomes an exponent. Ooh, but 8 to the 1/3. We just learned about 1/3 power. That's the same as the cube root. And the cube root of 8 is 2. Ooh, expand using the product power property. So this means I'm going backwards. Instead of pulling that exponent in, I'm going to push it back out. And there's reasons you might want to do that when you're solving equations. Exponent goes back out. Now, be careful because there was already a 3 in front. So that's going to be, this exponent goes out. Ooh, I don't see an exponent. Well, we learned earlier that the square root could be written as w to the 1/2 power. Now I've got an exponent. The exponent can come out. So that's 1/2 log base 7 of w. Let's put it all together. And here's a little place for you to go back through and see if you can rewrite your rules over here. I'll put a copy of that up as well. Okay, so condensing. It says condensing. This means I'm going to condense it down to a single logarithm. All right, so let's think about order of operations. We do exponents first, right? Exponents first. So when I make that an exponent, that's log of 6 squared minus log of 9. 6 squared is 36. And now I'm going to do multiplication and division. So subtraction here turns into division. 36 divided by 9 actually gives me a nice, pretty answer. Exponents first. Now, we have to make sure the bases match. I forgot to mention that here. They do. Addition condenses using multiplication. And there's nothing else I can do. That's pretty. Exponents first. There's already an exponent there. We have to think about what we do there with that. So here's log base 4 of u to the 7th. That's easy. Minus log base 4 of, now if it was already v squared, and then I'm doing v squared to the 3rd power. Power to a power, you multiply. Subtraction condenses with division. No exponents. So we're going to do our order of operations. Whatever comes first, left to right. So these are being added, so we're going to multiply them. And I hope you can do 15 times 4, that's 60. This is going to be division. 60 divided by 6, that's 10. I see an exponent, or what will be an exponent. So I see this number in front. That's going to come up here and become an exponent. But order of operations says I'm going to do these two first anyway, and they're being added. So that means I'm going to multiply them together. This becomes an exponent, and let's think about that. What does it mean to have an exponent of a 1/2? Well, that's the same as the square root. So that's the square root of 49. So I'm going to come off to the side. 49 to the 1/2 is the same as the square root of 49, which is 7. I should have put that in parentheses. That makes it better. So now I'm going to multiply these arguments together. Notice that it combines with a simple 1 logarithm. It's the arguments that combine. So 4y times 7 is going to be 28y. We got some options here. What do we want to do? Let's see. Well, I think I want to distribute. Now let's see if you can kind of work with me on this. Let's see if we can do this all at the same time. This is going to become an exponent. Become an exponent. I'm going to end up multiplying these arguments together and then dividing by that one. Ooh. Did you follow that? Exponents went up. Then this addition becomes multiplication. Subtraction becomes division. Now, to the 1/3 power means the cube root, so that's going to become a 2. Times the cube root of 27, which is a 3. That gives me log base 5 of just a 2. That is so much simpler than what I started with. Exponent comes up. Now 4 to the 3rd power, I don't know off the top of my head. So I'm going to grab my calculator. 4 to the 3rd power, and it says that's 64. Subtraction combines with division, and that's going to be a 2. Hey, log base 2 of 2 is 1. Simple. Log of 36 minus log of 2, because of the 4th root of 16, plus log of 3. Now be careful here. We got to do our order of operations. We're going to do these two first. These combine first. And they're going to combine with division. 36 divided by 2 is 18. Plus log of 3. Now these two combine with multiplication. 18 times 3 is 54, and we're done. Expanding means to separate it all out completely. These are actually my favorites. So, everything up here is being multiplied. So it's going to expand with addition. Exponents can go to the front. Now, could I have also wrote that as log base 6 of z plus log base 6 of z plus 4 times? I could have. But this is appropriate. This is being divided. So I'm going to separate it using subtraction. Exponent can go to the front. Done. For this one, I might do an extra step first. Since all of this one's getting squared, my screen's being slow. I'm going to do a little bit of simplifying first. If I'm squaring everything, that's going to be q to the 8th, r to the 4th. I like that better. Now I can separate it out, and since they're being multiplied, they're going to separate with addition. And then the exponents can go to the front. Since everything's being squared, I can simplify that first. And then separate it out. Now let's see if you follow this. Why did I use subtraction? Because these are being divided. Where did the 2 come from? The exponent. Where did the 10 come from? The exponent. Last two are a little bit harder. This is really to the 1/2 power, right? So let's rewrite this as log of 7 to the 1/2 and then x to the 3/2, because the square root of x cubed would be to the 3/2. Now I can separate it out. And that's it.